So. So you get this. You have to. You get four.
Why are you?
Yeah, I don't know where to go.
I would.
Yep. Oh, you make this trapezoid.
You do what? Why?
I don't know why.
Yeah, why? Something. Wait, this is
Understand the side.
Would like to show us? You want to show us?
Oh, hey.
Everybody want to show us? You want to get a marker and put it up?
I vote Max should show it.
Yeah, I got Max.
That's interesting. Yeah, isn't been nominated.
Oh, I see what you.
Maxie, do you want to do it?
I am. You're the not too sure.
He's not too sure. Maybe one of the nominators want to do it.
I don't know.
No, no.
Oh, isn't there something around these? Oh, yes.
How do you know? Did you know how to do it?
Oh, Ronan, you want to try it? No?
Rona, should we go up together?
Wait, are opposite angles on a trapezoid?
Oh,
Yeah.
I don't remember that.
Are opposite angles on a trapezoid?
Okay, so we got Ronan and Max tag teaming up here.
Supplementary?
There's something.
Oh,
I have two different colors. You like?
Yeah.
So what do we think? I think we make like combine.
Yes.
I think these two. Well, these two.
Interesting.
Instead of these.
Well, we had a kite. We had a.
Okay.
we had
Okay.
a
let's
kite.
do that.
Right.
Do that.
Yeah.
Interesting.
Oh.
Oh, that's it. Oh, wait,
Wait, is it a kite?
Equidistant.
Then we have
No, exactly, it's only when.
We have this one.
Okay.
Those are gonna be 90 degrees, right?
What?
If it's a kite,
Equidistant theorem.
No, it's like a triangle. If it's like the center, it like makes triangles that are already.
What?
No, but
Yeah.
that's only been this.
is it a kite? This quadrilateral?
Why? Does it form a right angle? Wait, you can say that
Yes.
four angles are. Well, you gotta.
Kite definitely has to be at this. Right, for a kite.
Right, yeah.
Okay.
The angle close to the A, I'm sure it could be your complement.
Sorry.
Like,
Yeah, we don't have enough information.
Wait, do we have?
Oh, so we need to prove it's a
Do we
kite.
have any givens?
Yeah, the given is we're dealing with two
It's not a
chords. And it's a circle. Yeah, two chords. Inscribed. Here we go. Inscribed in a circle.
Let's ignore the kite and let's just focus on the shape.
Anybody
No, dude, I'm telling you, complementary.
else want to come up and help?
Either complementary.
Supplementary.
The supplementary.
Yeah.
The opposite, like, the angle closest to A.
It's
It's like 2x plus 2y.
Going to 1, 2,
You can say
3.
x plus
You
y.
want some numbers there?
You can say that, like, there's
Well, what do you think?
Well, you guys already have.
Here we go. Angles 1, 2, 3, and 4.
We need to find the perpendicular. There's that x and then the other one. Now you guys-
This one?
No, one. We got up.
Okay.
All the way down, all the way down, all the way down. all the
All
way
right,
down.
okay, what are the?
Gentlemen, it was a valiant effort. I appreciate you coming up.
I thought like if we went up and did it like interactive learning, we would have maybe gotten.
Probably if we had a little bit more time, I think it would happen. I think it would happen.
I didn't go back. You know?
They're on the right track. You have to identify a pair of triangles. It doesn't matter which ones, but they should be opposite. I'm gonna do this one just because that's a short segment, and this one, short segment. And yeah, you're right. These, of course, are congruent. So are these two triangles similar?
We don't know, we do.
Well, they have the same like angle.
Okay. They have the same angle at the top.
It's the like, their sides are.
1, 2. Oh, what's this? Which angles are you talking about? Angles 1 and 2. Do you guys remember intercepted arcs?
Oh, that's.
Oh, that is how that works.
Sorry.
What do you want that?
Right.
Oh, we just drew two.
Rona, we were getting.
So does that make sense that that points to angles
Great.
1
Oh, yeah.
and 2?
Oh, that's ideal.
Sure.
These are. Similarity.
And now we know the triangles are similar because of angle similarity, and that's how we know that the sides are not just the sides, but the corresponding sides, right? Are proportional. So you would say that A is to we could say A is to B. Would that be
No, A is to D.
A is to D, right? And we know this correspond because
They're the same, they're the same.
they're in between those marked arcs, right? A is to D as C is to, are we sure it's B? How do we know it corresponds?
The other side.
The opposite from the double arc plan. And from here, of course, we get AD is equal to,
You wrote a B.
oh, I sure did. C is to B, excuse me, thank you. A times B equals C times D.
So,
Well, that was a nice little walk down memory lane, wasn't it?
Is there a theorem for that?
For the segments? Yeah, I think it's like the chord segment. I don't, chord segment theorem, not secant, right? Secant is when we come out like this, like that. It's interesting, you had all these words that kind of foreshadowed what you're gonna be doing in trig. A secant, tangent. Okay, let's continue with the unit, shall we? Let's do it. Today we're talking about the law of sines.
yeah. Okay, click solve.
Okay.
It's just like,
Have you heard of the law of sines
Basically, review.
on the review sheet? Oh, it mentioned the law of sines on that green sheet. So, okay, now you're gonna know what it is. Has anyone studied the law of sines?
oh, just like,
Exactly, for ACT, that's what I was thinking. Yeah, those of you taking ACT have probably studied or been exposed to law of sines. Okay, so let us begin. I'm gonna ask you to just put your pencils down for now. I'll give you a chance to copy it down in a second. We're gonna start with just a triangle. Again, keep your pencils down. This is our A, B, and C. So of course you know that this would be little a, little b, and little c. Did I do that right?
Yeah.
Now, if this were a right triangle, we could use Pythagorean theorem, and we could use sine, cosine, tangent, secant, cosecant, cotangent. But if it's not a right triangle, is there any way to talk about relationships between sides and angles?
The opposite.
We could talk about right? We have opposite from A, opposite from B, but like I don't have an equation that would relate the angles except they all add up to 180, or the sides except A plus B has to be greater than C, or A plus C. Do you remember that? Like A plus C is that one, the little A plus little c. Sum of any two sides of a triangle need to be
bigger than.
greater than the third side.
Okay.
But we want a more direct relationship. So what I'm going to do, and again, just pencils down, just enjoy. I'm going to create this, which is called altitude or height. I'm going to label it as an H because A is already taken. And I'm going to make two equations from here. One of them, since we have two right triangles now, I'm going to say that sine of A is
H over B.
H over B, and sine of B is
A.
H over A. Could I do sine of C?
No.
That wouldn't make sense. It's not part of a right triangle. So I'm just going to keep it with these two. And I'm going to combine them because they both have H. So we know that H is equal to B sine of A, and H is equal to A sine of B. So from here, B Sine of A is equal to a sine of B. Yay! So just like with the warm-up today, this could be rewritten as a proportion. What I'd like you to do is actually go ahead and copy up until this point, and then I'm gonna open a window so it's not 1,000 degrees in here. Maybe we could bring it down to 912.
Oh.
Wait. So an angle has a sine even if it's not part of a right triangle.
Yeah, that's why I had to cut into two right triangles. Because it's a sine of the angle, but we can't say opposite and adjacent. Yeah. We're good? Seems like most people finished. To finish off this idea, what I'd like to do is make a proportion. Now, if I write sine of A in the top left of the proportion, then something is forced, one of the quantities. Now remember, I want to have an equivalent to this equation here. What is forced if I put sine A in the upper left? Does it make sense that little b is forced to be bottom right? Does that make sense?
Right, yes, right, sure.
And then the other two, of course, have to be
Bottom left. I guess.
Uh,
Oh, no.
These, right? little a and sine big B. I'm gonna put the signs go on the top for law of sines. So sine of B is gonna be here, and then that means A is over here. This is the first part of the law of sines. There is a third part. Could you guess what it is?
D over C.
Sine of big C over C. This is a law of sines. Is it a formula? It doesn't seem like a formula. It just seems like a property. So this is something we're going to be using to solve triangles if they're not right triangles. If it's a right triangle, just use Pythagorean theorem, sine, cosine, tangent. But if it's not a right triangle, use law of sines. One property of these proportions, by the way, is that they could all be flipped. So we could say that we have A over sine of A equals. Did you already memorize this? You memorized it, right? It's not difficult, hopefully. And you just use it as appropriate. Okay, so let's try some problems, shall we? Let's. Okay, so we're solving this triangle. When you're solving a triangle, I'd like you to get into the habit of putting all your information together as such: A, B, C, A, B, C. So here I don't know A or A, but I know that big B is 45 degrees. I guess this is 5 and 95 degrees.
Bigger than 90 degrees have a sine, because
Yeah, it goes up to infinity, right? Unit circle. It's not practical, is it? Like there's no opposite, there's no adjacent, but there are values, and that's one of the reasons we studied unit circles, so that we could break out of that acute angle territory. Because it is weird to think about sine of 95 degrees when you're stuck in right triangles. Okay, I'm gonna give you and your neighbor a chance to solve this triangle.
later fair game or.
Absolutely. Except for that 45.
Sine 45 is pretty good. Angle A would be 40 degrees.
I think that.
Sine.
Angle A would be 40.
So, what do we have here?
We use this phone.
Oh, yeah, yeah.
Would that be the triangle? Oh, number. Okay, yeah.
That's just a mistake.
Sine 40.
Wait, is it? Oh, wait, they were- Sine.
I got a little A.
50 plus 95, 125.
I just drew the.
Oh, like,
I'd like 45. Leave right side.
135.
So be 5 sine.
Yeah. Five, so we know that. 5.
You say sine sine C over C. Sine C over C.
My God,
Well, isn't it?
I'm such a fool.
Oh.
You know the sine 45. There's H over there, you know, sine 40. So that A sine. Sine 40.
We haven't done a problem like this, so you're getting through it? I think you have the tools.
Reaching inside.
Well, 3 decimal places.
For length, 3 decimal places, for angles, 1 decimal place. I'll call on someone in about 10 seconds to start us off on this at least. Okay, Ria, can you help us with this? What'd you do? I have no idea what to do. Can you just help me, tell me where to start? Okay, so you notice that these are 140. Say A is 40. Okay. Are we good with that?
Yeah.
Nice. Keep on going.
Okay, and then you did. 40.
I can't hear, I'm sorry.
I'm still working on the full problem. Can I finish it then?
Did you get one more step?
Yeah.
I'd like to hear a step.
Okay, so we did sine, okay, so. Using the law of sines, we did sine 95.
Sine of 95.
Wait, where are you?
45 over, I'll call that B. Are we okay with that, everybody?
5.
So about 3.549. Did anyone else get that? Great. It seems like you're ready to stop, but you already had so much more. That's great. Thank you. 3.549. Should we use Pythagorean theorem here to get that B? No, that'd be inappropriate. So Ria, did you want to stop here or did you want to at least give us the next step? Is equal to what?
Sorry, sine.
Nice. Perfect. And from here,
And then.
were we able to solve it yet or? Okay, who could tell us what they got for this? 3.23?
226.
226. 3.226. For length, unless otherwise determined, unless otherwise noted, I want three places, absolute decimal. For degrees, I just want one. Why do I just want one for degrees?
Like 1/60.
It's so minute.
Yeah, 1 degree is already tiny, isn't it? Like, think about the difference between 59 and 60 degrees. That's not even noticeable already. It's already tiny. So just a tenth is necessary. Ria, that was fantastic. Thank you for your help. I do have a recommendation. Although law of signs is normally thought of with sign on the top, I like to begin with the unknown first. So I would start with saying B, like I'm very purposefully looking for B. So I'll say B over sine of 45. Recommendation. Sine of B over sine 45 is equal to 5 over sine of 95. Now you see when solving this, with B on the top, all you have to do is, make sure you're paying attention here. With B on the top, all I have to do is
Same thing, you multiply that.
multiply both sides by
45.
sine of 45. Whereas if you start here, you're probably going to want to cross multiply and then divide. It's one step instead of two.
It's just a B, so you can say, oh, sine of 45 times 5 divided by sine 90.
Oh, from here, you mean? Yeah, it depends on how fluent you are with the algebra. But with the variable on the top, all you have to do is multiply by sine of 45. It's up to you. Suggestion. Yes, Charlotte. Well, if you aren't, you would be leaving it in calculator ready form, which would be fine. It's just 5 times. I would expect you to do sine of 45. You do know sine of 45, don't you? Root 2 over 2, and then sine of 95 degrees, which would be a little bit nicer to write as this. At that root 2 over 2. Did someone just scream? What's that? Just got an A on something.
That's not.
Right, so this is my answer calculator ready. I do expect you to be able to do sine of 45. I do not expect you to know sine of 95. Sine of 90? I expect you to know that one is 1. So sine of 95 is just going to be a little bit more than 1. Sine of 95 will be a little bit less than 1, of course. I'm sorry, Mitra. Oh, I definitely want you to use subtraction or addition if you are subtracting, adding angles. Which one are you talking about? Like 95 degrees?
How would you like, for example, like sine 45 plus 35? That we learned last.
Yeah, I think if it were a sine of 75, then you could evaluate that using like 30 and 45, but 95, I don't think you break it down into anything that we know. Thank you for thinking that. Appreciate it. But that is interesting. I guess you could technically make this 120 minus 15. Oh, no, minus 20. Is it 20, 25? We don't know that one. Could we make 95 with any of the angles that we know? Yeah. I don't think so either. Okay. So just leave it like this if it's non-calculus. And that would be an exact answer. Anything else is an approximation, which reminds me, this should be approximately equal to, and I think you said 3.226. Is that what you said? 3.226. I think that's what. Okay.
So isn't it reversed?
I think it's
Oh, did I reverse it? Two, 2, 6. Thank you. Oh, and one of the reasons to leave it like this is so that you could just make sure everything's in order. What do I mean by that? Check with your neighbor. What does it mean for everything to be in order? If you look at it like this.
It's like. Yes.
Like,
Number being
yeah.
small thing.
Oh, yeah.
I guess.
So you see what I mean? 5 is opposite from that biggest angle. Smallest side is opposite from the smallest angle. If it weren't that, then you have to go back and find your error. Which is hard to do if it's calculator ready, of course, but I think there will be calculators allowed on this exam, on this next exam. Probably not.
Oh,
Oh, yeah, about that.
Wait,
Pardon?
wasn't it British?
I will see. Let's see what we can do for number 2.
Yeah. It's one of those things that they use.
Alright, actually.
94. Oh, no, 97.
Slide it out.
Well, there you go. Nice. Yeah, I think
I'll be calling on one other person in just a moment, so make sure you're making headway.
Get in.
Good. Yeah.
Yeah.
Are we ready?
Mr. Lieberman.
Yes, sir.
Number in my calculator.
Okay.
I do sine inverse of that.
Oh,
Yeah, you can't.
Yeah.
There's
There's no
cosine, it's not secant.
Like, would I have to?
Usually I don't want to stop. You think you'll say.
Oh, that's so.
Usually one of three or less. There's no second cosine on it. Usually 1 divided by cosine. Oh, anyways. You can cosine? Yeah. There's no secant on it.
Second. Domain error?
okay. It seems like some of you moved on to number 3, which was we have to talk about number 2. Maya, Destiny has been chosen you to help us out. How'd you do number 2? Okay. So what did you get? We're just gonna hide that from us? Okay. Did you draw it by any chance? Okay.
Solve for, A, like the side A, by doing sine 40 over A is equal to sine 92 over 2
Say it one more time, please.
is equal to sine 92, which is big C.
Okay.
Solve for A.
Can you walk us through the steps that you did to solve for A?
Sine 92 divided by 2 divided by sine 40.
You did sine 92 divided by 2. Okay, that makes sense. Sine of 40 degrees equals a sine 92, is that right? Okay, and then,
Sine
nice.
A is zero much. So.
Approximately what? 1.286, you said? Okay, do we agree with that? Did anyone else get that? 1.286? I'm saying one thumbs up.
Yeah.
Okay,
That's fine.
cool.
Just-
Thank you. Can you just tell us your answer for the next one? 1.487, do we all agree? Thank you very much. One thing that some people are tempted to do, I don't know if you did this, but like when you're looking for that last one was B, maybe sine of 48 over B. There are some students who would use sine of 40 degrees over 1.286.
Terrible.
What's terrible about this?
It's because it's not an exact.
Yeah. When you have a choice, please use the exact numbers, which I imagine you did. So just please keep that in mind. Yes, Mitra? Or is that what you're going to say, that it was not the exact one, or did you have a question, or? I thought it. Oh, okay. The danger of stretching in a math class. Any questions? Okay. Before I move on, how do I say this? I try not to waste your time. I do try for what I say to be helpful. So please consider when I give you tools, then consider tucking away and using it when appropriate. Like for this last problem, I recommend, you don't have to, you'll still get the right answer, but my recommendation, if you're looking for B, start with B over sine of 48, and then compare that to 2 over sine of 92. Now, is that the same thing as this?
Yeah.
They are the same thing, but what's the benefit of what I just recommended?
And calculator ready.
It's almost, you're one step away from calculator ready. Do you see that? Exactly, you just had to multiply by sine 48 on both sides. You have a calculator ready already. Here, you could do it other ways, but mostly cross multiply and then divide. It's 2 steps instead of 1. It's up to you. I'm just saying, when I give you a tool, think about it. Think about it. We are skipping 3 because there's a problem with it.
Yeah, it doesn't.
Doesn't work.
We'll talk about that next time. But number 4 works. Let's see what you could do. And Maya, thank you for your help.
Good plan.
Why are you? What? Mr. Lee.
Yes, sir.
What's the talk?
Oh, I know. It's just, yeah, oh, I'm so sorry, I got 7 times for the. You get like 0 for me.
Did you get it? If you're calling one happy person, make sure you discuss at least one fact. Are you ready? Okay, Max, can you help us out with this, please?
Sure.
Thank you.
So first I drew it out,
Okay,
labeled everything, so. 20, and then big small to 7. And so I did sine C over 7 is equal to sine 20 over 4.
Okay.
7. I didn't get the calculator. I didn't calculate it, but it's like the inverse of that.
nice. So calculator ready would be C equals sine.
Sine inverse of sine or 7 sine 20 over 4.
Are we good with this? Nice. Thank you, Max. Who got an answer that would help us with this? What is it? 37, 37, 36.8 or 0.9? 0.8? Okay. I want one decimal place.
Oh, kind of slow.
Cool. So, and it's approximation, so I'm going to change this to a little approximate sign. 36.8. And max, of course, from there.
So I subtracted from 180 to get the angle A.
Okay. So this is about 56.8.
That'd be what? 3.2.
An approximation.
Then you would do small a over sine 123.2 is equal to 4 over sine 20.
Any questions? And then from there, you get that A is approximately, did anyone get that?
7.
9.7, 9.782 or 86?
It is.
But 8.
I think it depends on if you're using exact, not
Exactly.
You're at 782.
782 with using the exact values.
Yeah.
1.7.
Yeah. it's-
1.782.
If your work is right, you're okay. Let's see, let's put some degrees on here. Do we need the diagram to do these problems?
It's helpful.
It's helpful, but like if I take us back to where we started, do you see that you could just do law of sines given this information, right? You have your B over sine of B, C over sine of this. Fill this in. So,
Wait, but that's not where we.
oh yeah. We started with, what was this? We started with?
We-
Oh, there's a 4 here. Okay. So it would be a sine of C over some. So it's even just with that information, you can see you don't really need the diagram. It could come in handy, especially if things get a little bit wonky. Let us go to this one. Of course, the whole reason for this is to apply it to real world problems. I think the full text is in your packet.
Use at the end of the whole bunch.
Sure.
Yeah.
Yeah, okay, you,
I guess.
That's it.
I don't think so.
you know, not entirely sure.
Where's Q? Oh.
Oh, yeah, that's. Yeah.
No. I went pretty interesting.
I call him in about 20 seconds.
65 stated. Yeah.
So it's what the same as it is.
Yeah.
That's a good sign.
Good
Good sign. Thank you, Max. Okay, ready? Ready or not, Sage, what'd you do?
Alright, so. Basically, I found the measure of angle QPR first because, yeah, it's supplementary with 25 degrees.
Nice.
So I found that was 155 degrees.
Okay,
So that means that means angle PQR must be 10 degrees. And then I just used law of sines where I found the sine of 15 over PQ is equal to sine of 10 over 1,000.
should we give PQ a name?
Yeah, we'll give it like X.
X, okay, X is fine. Over X is equal to what over what?
Sine 10 over 1,000.
Are we good with that, everybody? And then from there you get X is approximately equal to,
1490.47.
479. Does that coincide with yours? Nicely done. It seems like 3 decimal places is in the scope of 1,490 feet. It seems like it might be a little bit too exact, but again, without any other information, I do always want 3 places of accuracy for length. Okay, we will resume at 2:36. You have some time to zone out, stretch.
Great question for you.
Yes, sir.
We have 2 days on this.
We do. Yeah, there are some nuances. Introduction to law of cosines.
But no, because we have 2 days on.
Yeah, today and then it's not a full quiz.
What?
We'll see what's happening. See what happens Friday.
So I'm just sorry, like there's
Did
only.
you get like the notes?
I don't think so. Probably did. Maybe I just did. Let me check.
I'm-
Oh, that's you. You're right. I did. I'm sorry. I was away this weekend.
Where did you go?
With my father in Texas. Yeah.
Oh,
Yeah. I'm sorry. I didn't reply. I'll take a look and reply to you.
I think I've seen like.
I see Bear.
No, they didn't make it. When you start something.
It's the more Bear.
Yeah. But like, I don't know.
Very-
And eventually.
oh, with the bearing.
I don't know. That's the way.
Both got canceled.
It's very much so.
The hitting? Mr. Offsetting it.
Oh, yeah. Thank you for you got it, right? Thank you very much.
Yeah, bro, big.
Yeah.
So alleged, according to that.
I thought he meant like we were gonna have one today and tomorrow.
Yes.
They're actually both.
And we were actually. She wants to hang out. Okay,
You're done.
Great.
Yeah, I think so. I mean,
One should be really fun. Really good.
Yeah. It's probably gonna be after.
yeah.
No, it will be while we play power.
Oh, I know what that is.
All right.
So there's Glades, everyone.
Yeah, I can't.
Let's go.
Imagine.
That'll be fun.
Okay.
70% of worry.
Is what is
There
your?
were a bunch of white boys. You were talking. It's unbelievable.
Okay, folks, let's finish this up.
It wasn't. Yeah.
Okay, folks.
Uh-oh.
Yes. Oh, yes. I'd take a minute to read through this and see if you could draw a diagram that would depict the situation. If you have a really hard time, to consult with your neighbor and we'll bring it all together. So you're making the diagram for the situation for number 8.
Postcard station of Bell. I'll give that. Due south.
Oh, it's a two-parter.
Circle.
That should be a ship.
SOS.
Yeah, the ship. It-
55 degrees.
You know, he's never eats good.
This way.
Typo.
Oh, no, I do.
Interpreting. It's saying. No, because it's north 55 is because 55 A is the one on the south.
No, I
This
think
would be
the station is,
from the station's perspective. It's 55 degrees.
Oh.
I think that the station. Perfect.
It's like.
I mean,
No, because since north is pointing at south.
Yeah.
Oh, so this is
So it'd be
station.
55.
Oh. It's like this and.
Yeah, all right.
Are you getting a picture of it? You coming together? Is it?
Yeah, it's actually coming together.
This is 150 miles. This would be, say that's A, so it could be small b. So it's very good here. Write it out. The big A is 65. Let's say B is 55. So we do small signs.
Okay.
Small b, sign of
No,
55
you can put over one.
equals 150 times.
Okay. Who could start us off? What should I do here? It says Coast Guard Station Able is located 150 miles due south of Station Baker. So we're going to draw. You did 2 points, right? Let's call one A, the other one B. Which one is on top?
B.
Are we good with that? Nice. So a ship at sea sends an SOS call that is received by each station. The call to station Able indicates the bearing of the ship is 55 degrees east of north or north 55 degrees east. So that is from Station Able, can you show me what direction that's headed approximately? So you start at the north and you go 55 degrees east. Are we good with that? So we need this to reference that north and then maybe something like this. And we don't know how far it is. That's the whole point of this problem. But it's somewhere in that direction. And then from station Baker, the bearing is the ship is south 60 degrees east. So from south, we go 60 degrees east.
Equals X.
So somewhere in this direction. So I think we found where the ship is.
Yeah.
Okay, I'll give you a time to work this whole thing out, A and B.
It's due on right
Let
now.
me see it.
Oh, it's just one digit is fine.
I had. Yeah. I flipped one.
I got 1409.8, it was like you said, 1495, so.
Oh, look at that. I was like, tell me what's right for one thing. They're all gonna be similar.
Wait, no. Wait a minute.
Yeah, I one thing wrong.
Okay, I want some help.
Wait, let's-
Charlotte, can you help me with this, please?
I did the third angle is 65 degrees.
Nice.
And I did sine of, oh, I did 150 miles.
150, okay.
Sine of 65 degrees.
Over 665, okay. So I'd like to just Charlotte, please.
Is A over sine of 60 degrees.
And you're calling this A?
No.
Okay, so you're calling this one A? Okay, right, it's weird with this one, but I think it makes sense to do what you did. So A over sine of 60 degrees.
43. 333.
Do we agree? So 143.333. So here it might have been just helpful to just use X and Y, something that's not related to points we already have because we're used to the opposites being a certain relation, but that's perfect. Did you get the other one by any chance?
Sine of 60 degrees equals B over sine of 50 degrees.
Nice. And what did that give you?
135.57.
575. Okay, any questions? Thank you, Charlotte. Part B, the last thing we're doing. The helicopter capable of flying 200 miles per hour is dispatched from the station nearest the ship. How long will it take to reach the ship? Are we supposed to do this? Problem. D equals R times T. And we're doing from where? Station Baker, of course. So distance is 135.575 equals 200 times T.
Divide that by 200 and
So what are we left with? 0.6. 0.67 hours. Is that right? Oh, 0.7? 0.7 hours? 6, 7, 8, really? Interesting.
If it's a fraction of an hour, like, do you want us to give it in minutes or in hours?
I think tenths of an hour is fine, but if it says minutes, you should be prepared to do that. How many minutes
So
will
you
it
can
take?
say that that's 0.7 hours.
Yeah, 0.7 hours is fine.
Percent minutes you can multiply. Conversion.
Okay, you have a little bit of time to work on your assignment. That's all I got for you for today. Sure.
Yes.